Hey class, welcome back. Happy Monday. Mr. Helson here for another space science lesson, Gravity Reads Everything, Part 2. Um, so hopefully if you did Part 1, and if you haven't, like always, make sure you do that first. At the end, I asked you to kind of do your own experiment, finding two pieces of paper that were the same size, crumpling one up into a ball, and one keeping flat, and keeping them at about the same height, and dropping them as close as you could to the same time, and observe what happened. So, how did it go? What were your results? Um, you know, Hopefully you shared those with me, but kind of think of those now. Well, spoiler alert, if you haven't done it yet, maybe skip ahead a little bit. Obviously, the crumpled up ball hit first, and the paper usually floated around for a little bit. But why is this? Both these pieces of paper should be just about the exact same mass, the same kind of paper. There was no writing on it or anything like that. They weigh the same. Yet once you crumpled one into the ball, it fell to the ground much faster than the flat paper. So why is this? Why is gravity acting this way? Well, maybe it's not even gravity that's doing this. A long time ago, a philosopher and scientist named Galileo had to do, he wanted to test this, and this is called the Leaning Tower of Pisa experiment. He had two cannonballs. One was much bigger and heavier, a larger mass, probably the size, of a big bowling ball, and then he had a smaller one, much smaller and lighter. And during his time, what most people would think if they aren't thinking about gravity's pull on everything would say, okay, yeah, the heavier one's going to hit first, right? Something heavier is going to fall faster. That just kind of makes sense to us, right? Something that is heavier is going to hit the ground first. And so he put that to the test. So what if gravity is pulling all things towards the center of the earth equally, then maybe they could hit the ground at the same time. And this is very famous. This is hundreds of years ago too. And so this is the old idea, right? You'd think that the heavier cannonball would be much faster and hit down before the smaller one. But with the Galileo experiment, this is actually what happened. When it's done right and things are falling at the same rate, they they actually stay the same. They hit the ground at the same time. And that was a big deal. Doesn't matter how heavy an object is. Um, but if that's true, then what happened with your crumpled up paper and your flat piece of paper? Interesting. So we're saying that gravity pulls on all objects the same, but something else is happening here with the cannonballs. They hit the ground at the same time. That happens. So if you have two things of different weights, they will hit the ground at the same time, but there's something else that happens. So let's think of this one. This is also very famous. Which one of these do you think would hit the ground first? The hammer or a feather? Hammer's a lot heavier, more compact than the feather. Well, hopefully you've already predicted what you think would happen. Spoiler alert, the hammer would hit the ground much faster than the feather. But with Galileo's experiment, he showed that it shouldn't matter what the mass of an object is, it's going to be pulled down at the same time. So something else is happening here. And I want you to take a minute and think about this is pretty unique to the Earth and the Earth's atmosphere. Okay? Got it? Maybe? Well, you're breathing right now. This magical stuff called air, this gas around us, right? Oxygen, nitrogen, argon, and some other stuff. Air is a thing. We can feel that. I talked earlier in the year about air pressure on you. There's a weight of a watermelon every inch of you. We have this stuff called air. And we can use air to resist the pull of gravity. So depending on how spread out things are. For instance, your paper. When you crumpled the paper up, and it's not flat out, there's a lot less air resistance when the paper is crumpled up than when it is flat. And when it's flat, it kind of acts like a wing or a hang glider, right? It's brushing up against all those little tiny, you can't even see, microscopic air particles resisting against that. And that's what a feather does, right? That's where feathers are on birds, because they're really good at flight. They're really good at dispersing their mass and floating down gently. Where a hammer is, pretty solid metal. It's not really spread out. So that's the thing of this important thing of air resistance versus gravity. Much like how a parachute works when someone is skydiving to slow them down, right? You see the parachute is spreading out the skydiver's weight. This is air resistance. The little dots are representing air as friction, the particles of air, right? It's there, just we can't see it. We can hardly feel it. Gravity's still pulling you down. If you are on a parachute, you're still going to get to the ground eventually. But the parachute's job is to create air resistance, to slow you down. It's basically catching air and keeping it from falling down too fast. That would, hurt you or kill you. So that is air resistance. You probably come across air resistance every day. If you're throwing an airplane, if you're throwing a football or a baseball, you're up against air resistance and gravity. If you are riding in a car and the windows are down and you're feeling that air, that is your speed, the speed of the car going against the air, and you can physically feel the air much more easier in that case. So air resistance can slow an object down as it's falling in gravity, but the pull of gravity is still the same. So maybe there's a place we could go where there's no air. So where can we go that there's no air? And maybe do this experiment with the hammer and the feather. Now, if you thought of space, you're right. There's no air in space, especially one spot that people have been, that astronauts have been to in space, the moon. So in your next video, you're going to watch the actual hammer and feather experiment done by an astronaut on the moon. It's really cool. So the moon is a vacuum. There's no protective atmosphere. There's no air on the moon. That's why you need those spacesuits. That's why they need air in their backpack and oxygen that goes to them through their suit, or else you wouldn't be able to live on the moon. You wouldn't be able to stay there. They need all sorts of protective equipment. I'll go into that a little bit later. But one astronaut he has a hammer and he has a falcon feather, and it was just kind of like a little fun experiment that he did in camera. Remember, this is in the early 70s, so the quality is not what you're used to, so bear with it. That's a long time ago. And he drops them about the same time, and you're going to see what happened. So I have this video for you to watch after this, and then there's another Crash Course Kids video about the same topic for you to watch after that. And you're going to answer the questions in the Google document. There's 2 questions about the difference of objects falling on Earth versus on the moon. All right, guys. See you later.